Hello, this is Miss Parks. Good evening, and today we're going to be finishing chapter 5 and doing half angle identities. So hopefully you have your identities page with you. We'll finally finish off that page. So we have cosine here. We have sine and tangent has a whole bunch of them. Okay, so tangent has 3, where last time when we did cosine, the double angle identities, cosine had 3 of them. All right, so the reason that there's a plus minus here in front of these is because you have to determine what quadrant the half angle's in, and then you can determine what sign it's going to be. All right, so when you want to know what A is, you're just going to double that number, okay? So A is equal to 30. So we already know from the very beginning that cosine of 15 is in quadrant 1, so it will be positive. So cosine of A over 2 would equal cosine of 30 over 2, which is equal to 1 plus cosine of 30 over 2. That's going to equal 1 plus radical 3 over 2. And since that's radical 3 over 2, I'm going to go ahead and make this, instead of a 1, a 2 over 2 over 2. At the top, so again, you always want to make the 1. That's always going to be a 1 here, and you always want to make it the denominator, whatever's on the bottom. Generally speaking, that's going to be a 2 because we're going to be dealing with sine and cosine and all of the formulas. So if you look at all of these, they all have a 2. That's not true. They all have a cosine or a sine, and every answer for sine or cosine is going to be either 1 over 2, radical 2 over 2, or radical 3 over 2. And therefore, the denominator will always be 2. So because that's a 1, we're always going to make it 2 over 2. It'll just be easier. Okay? So now, at the top, I have 2 plus radical 3 over 2. And then divided by, and I'm going to write this here as 2 over 1. So dividing by 2 is the same thing as getting rid of dividing by 2 and multiplying this by the reciprocal. Okay? And the reason we're doing that is so we can get rid of the 2 in the bottom. Okay? So that's going to give us, at the top, you're just multiplying 1 times 2 plus radical 3, which is just 2 plus radical 3. In the denominator, you're multiplying 2 times 2. So in the denominator, you have 4. Now, you cannot leave radical 4 or any radical at the bottom. So therefore, what you have is really radical 2 plus radical 3 over the square root of 4. And the square root of 4 is 2. Now, if that wasn't a perfect square, the square root of 4, we would multiply it so that it was a perfect square. Okay, and we'd have to multiply top and bottom. You don't really need this step. If you can see that that's a perfect square in the denominator, then you can go ahead and just simplify that out. The numerator, you can't do anything with that, so you have the square root of 2 plus radical 3 in the numerator, and that gives you the answer to the whole thing, which is cosine of 15 is equal to this. What I want you guys to do is go ahead and try the second one and see how you do on that, okay? It's very similar. You just have to make sure you use the half angle identity for sine. I'll already tell you, you don't have to guess on the plus or minus. We already know it's positive because this is in quadrant 1, sine of 22.5. So go ahead and do that and then pause the video. All right, so A is twice 22.5, which is 45. So you're going to have sine of 45 over 2, which is 1 minus cosine of 45 over 2, which is, remember I told you for the 1, you're going to make that a 2 over 2, plus radical 2 over 2, the whole thing over 2. We'll combine everything at the top, 2 plus radical 2 over 2, and then dividing by 2 is the same thing as multiplying by the reciprocal. So in the radical at the top, I have 1 times 2 plus radical 2. And at the bottom, I have 2 times 2. Okay, this is all under the radical. Again, I took this, flip, and multiply it. Now, the radical at the top stays. The radical of square root of 4 is 2. That's my final answer. It's positive, and sine of 22.5 is equal to this. All right, so here we're going to do tangent, okay? And when you use tangent, you usually want to use the one where you just have sine at the bottom. So there's all the formulas, and they have a whole bunch of things like binomials at the bottom for these. And this one has a radical over the whole thing. So generally speaking, you want to use the one that has just sine A on the bottom. It'll be easier. All right, so we're going to use A is 45. So tangent of A over 2 is going to be 45 over 2, which will be this formula. So it's going to be 1 minus cosine of 45 over sine of 45, which will have 1 minus 2 minus the square root of 2 over 2, and then on the bottom, square root of 2 over 2. So we have a fraction and a radical that we have to get rid of here. So it's going to be a little bit difficult. So what we're going to do first is we're just going to go ahead and multiply top and bottom by 2. That'll get rid of the fraction part. So at the top, I'm going to have 2 minus the square root of 2. And then on the bottom, these will cancel, and I'm just going to have radical 2. Now I need to get rid of the radical 2, so I'm going to multiply top and bottom by the square root of 2. So at the top, I'm going to have 2 radical 2 minus 2, and then at the bottom, I'm going to have 2. And then if you reduce this, again, when you reduce this, you're basically going to make a fraction out of both of them. So you're going to have the square root of 2 and then minus 1. Okay, and that will give you the answer to this. This is equal to radical 2 minus 1. All right, I would like you guys to try the next problem, please. And again, we're going to be using half angle identities. Okay, so you're going to be using this, not the sum and difference identities. All right, so I'm going to use A is equal to double that, so 150. So tangent of 150 over 2. You should have tried this already. We're going to use this formula over here. So we're going to do 1 minus cosine of A over sine of A. And A is 150. So then we'll fill these in. So it's going to be 1 minus, and then at 150, cosine is negative radical 3 over 2, sine is 1/2. So cosine is negative radical 3 over 2, and sine is 1/2, positive 1/2. So we're going to go ahead and multiply top and bottom of this by 2. So at the top, I'm going to have 2 plus radical 3, because this becomes plus when I distribute. And then at the bottom, I'm just going to have 1. So tangent of 75 is just going to equal 2 plus the square root of 3. All right, for this one, we have to find 3 different answers. Okay, they give us some information. So they tell us that cosine of S is equal to 2/3. So here's the deal. We need to find sine of S over 2. So I'm going to write the formula down, which is 1 minus cosine of S over 2. I have to find cosine of S over 2, which is 1 plus cosine S over 2. And I have to find tangent of s over 2. So for tangent, we have 3 different formulas to use. So let's just go ahead and start with the first 2. If you notice on the first 2, this cosine of s is in both formulas. I have to also decide what quadrant these are in. So they tell us where s is. So I'm going to rewrite this here, where s is, but we don't care where s is, we care where s over 2 is. We care where the half angle is, not where the full angle. So how do we do that? So we take the full angle, 3 pi over 2 is 270. 2 pi is equal to 360. So this is equivalent to this in degrees. Now, if I take all 3 of those and I divide all sides by 2, then I get 135 and 180. That means that the half angles are here in quadrant 2. And because the half angles are in quadrant 2, sine will be positive, cosine will be negative, and tangent will be negative. So when you have to make a decision here on the plus or minus, it's already been made because we decided ahead of time. Okay? So I could draw this out, but I'm not going to have to draw it out. And the reason I don't have to draw it out is because I have this 2/3 right there. And if I do tangent of s over 2, and I already have sine and cosine, I could probably do sine of s over 2 over cosine of s over 2. And so I'm already going to have these 2 answers, all right? So this is what I'm going to do. Let's just kind of put a line between all these, just so that we have some space here, and I kind of know how much room I have. All right, so for the first one, I have the square root of 1 minus 2/3, so I'm going to make that 3/3 minus 2/3 over 2, which is equal to 1/3 over 2. Remember that when you're dividing by 2, it's the same thing as multiplying by a half. So I have the square root of 1/6. Now, in the denominator, I don't want to have a 6. I want to make sure that the denominator is a perfect square. So I'm going to multiply top and bottom by 6. The only reason I'm multiplying by 6 is because I know 36 is the quickest way to get to a perfect square root. So now I have the square root of 6 over the square root of 36, right? So the square root of 6 over 6. So this, let me use different colors. Sine of s over 2 is equal to that. Actually, I think I'm going to go ahead and write it on this side. This is equal. All right, so we're going to finish this off, and we'll write sine of s over 2 over here, just so that it's finished off. Okay, so now we have sine, the half angle for sine. Now we're going to do the half angle for cosine. So the half angle for cosine is going to be 3 over 3, because we want to do 1, plus 2/3, that's what cosine of s is, because that's given, over 2. So now we have the square root of 5/3 over 2, which is the same thing. To divide by 2 is the same thing to multiply by a half. So now they have the square root of 5/6. And we'll multiply top and bottom by 6. That's inside the radical. So that's going to give us a square root of 30. That's 36. So that's 6. And that's equal to cosine of s over 2. Not s over s, but s over 2. And I'll highlight that in green. And now we'll do tangent. And so what we'll do is we'll take sine of s over 2, which is radical 6 over 6, divided by cosine of s over 2, which is radical 30 over 6. And we'll flip and multiply this. So that's going to equal the square root of 6 over 6 times 6 over the square root of 30. So what's going to happen there is these will cancel. You're going to get the square root of 6 over 30, which is the square root of 1/5. And we can't leave the 5 in the denominator. So we're going to multiply top and bottom by 5. And that's going to give me the square root of 5 over 5, which is tangent of s over 2. And that will be, I'll do that in yellow. Now, you're not always going to multiply by the same number. So for example, if the denominator, I don't know, was trying to think of a number, like an 8, then I wouldn't multiply by another 8. If the denominator was an 8, I would multiply by 2, because 16 would be the first number that's a perfect square. So don't always think that you're going to multiply by the number that's in the bottom. So here I multiplied by 6 because that's the first perfect square from 6 is 36. That 6 goes into. And anyway, excuse me, these are your 3 answers. Now, for cosine, what we didn't do, and I forgot to mention after I got all this, is that it has to be negative. Okay? So cosine must be negative, and if cosine's negative, that also will make tangent negative. Why? Because I need to make the denominator here into negative. Okay? And so because that's negative, which makes this negative, negative, and negative. So make sure you check at the end that your signs are accurate based on what quadrant the half angle's in. And the half angle was in quadrant 2. There's a lot to cover here. Try the next problem, please. All right, for the next problem, sine of s over 2 is going to be 1 minus cosine of s over 2, which will equal 1, which is in this case, it will be 7 over 7 minus negative 3/7. I'm talking about this value here, over 2, which will be 10/7 over 2. Dividing by 2 is the same thing as multiplying by a half. So that's going to give me, reduce that, I was going to say 10/14, but this is going to be 5/7. And then to simplify this, you're going to have the square root of 35 over 7, which is sine of s over 2. Now, I haven't decided if it's positive or negative, so s goes from 180 s here, that's in quadrant 3, and it goes from 180 to 270. So if I divide all those by 2, I'm going to go from 90 to 135. So we're in quadrant 2 again. So it's going to be the same signs as the one before. So in quadrant 2, sine is positive. Next, for cosine of s over 2, that's going to give us 1 plus cosine of s over 2. It's going to be 7/7 plus negative 3/7. Again, cosine of s is negative 3/7 over 2, which will give me 4/7 over 2. Dividing by 2 is the same thing as multiplying by a half. So that's going to give me 2/7. And I can't leave that fraction, or I can't leave a radical in the denominator. So square root of 14 over 7. Cosine is negative in quadrant 2, so this will be a negative. Okay? And then that will give me cosine of s over 2. And for tangents of s over 2, I will use sine of s over 2 divided by cosine of s over 2. So radical 35 over 7 divided by negative square root of 14 over 7. And again, we could flip and multiply. Actually, I could just cancel these out. So I'm going to get negative square root of 35 over 14, which is negative square root of 7 goes into that 5 times, 7 goes into that twice. And then we would have to multiply top and bottom by 2. So negative square root of 10 over 2, because that's the square root of 4. And that equals tangent of s over 2. And that should cover at least through that question. We have a few more examples to do. All right, so for these last 4 problems are giving us an equation. These are the ones where we're going to try to work it backwards and see if we can solve these and simplify. Okay, so first we're going to take the angle out of here. We're going to make it A. Please write down that A equals 12x. Then we'll rewrite this. 1 plus cosine of A is equal to 2. That is the cosine half angle identity. So that's equal to cosine of A over 2. Then we take the A value and we plug that back in. So it's cosine of 12x over 2, which is cosine of 6x. I do want you to know that if in this radical this was upside down, then it would be secant of A over 2. Okay, so if it was plus or minus the square root of 2 over 1 plus cosine of A, that would be secant. All right, for this second one, actually, go ahead and do the next 3 and see what you get, okay? So the first thing we're going to do is what A is equal to, and then see what you get when you do those 3 problems. All right, so this is going to be 1 minus cosine of A over sine of A. That's equal to the half angle for tangent. If you put 5 theta here, that's not 50, that's 5 theta. Then you would get tangent of 5 theta over 2, and that's it. Okay, for the next one, you're going to get plus or minus the square root of 1 minus cosine of A over 2. That's the half angle identity for sine. So you're going to get sine of 8x over 2 once you plug 8x back in, which is sine of 4x. And for the last one, we have plus or minus 1 minus cosine of A over 1 plus cosine of A. That's the half angle identity for tangent. So you're going to get tangent of 9x over 2. And I know that's definitely a lot in section 5.6. Once you practice these, you'll get better at them. We're done with chapter 5. And we'll take a quiz pretty soon.